sort of these expanding problems like this?
Mm-hmm.
Okay, so there's a couple of things you need to know to be able to do this. One is Pascal's triangle. Have you seen this before in class?
Yes, that I think that's the way he wanted us to do it.
Yeah. Now, do you know how this 2 is produced?
No, I actually wasn't even here when we learned this, so this is kind of like new to me.
Okay, so let me start fresh and we'll go through it. So there are always ones down the sides of the triangle. Okay, but I'm not going to keep drawing them because I want to show you how to get these interior numbers. So the interior numbers, this 2 is because it's the sum of 1 and 1.
Okay.
Okay, so you can imagine here, what is the sum of 1 and 2? Well, that's 3. And then this 2 with this 1 is 3, and some 1s on the outside. Now it actually indexes at 0. It's the 0th row, which is a little odd, but we've got to go with that. And then the first row has two numbers. The second row has 3. The third row has 4. And you'll notice that it's growing each time.
Yeah.
So there's always a 1 on the outside, but then the interior numbers, you start adding. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. So the reasonable question to say is like, hey, Mr. Teacher, hey, Matthew, do I need to memorize this? The answer is no, you should be able to build it. You don't want to try and memorize it on the test.
Yeah.
Okay. Now, in terms of how far do you need to go, it depends on this number right here, this exponent. So that exponent is a 4, so you need to go to the 4th row. But again, it indexes, and that's a computer science term or programming term. It indexes at 0, meaning you don't count it as the first, you count it as the 0th row.
Yeah.
Which is odd, but try not to get everyone with that. Okay, so that's Pascal's triangle. It goes on forever. Pascal was a very famous mathematician, but he's an old dead guy now. But we do credit him with this.
Yeah.
I wonder if he knew that this was going to be used in Algebra 2. It's used in a lot of other areas of math, but this is where it first comes up for you guys.
Mm-hmm.
Okay, now there's you have to look at this first term. I like to call it A, and you look at the second term with the sign and call it B. So like in another problem, it might be -3. Okay,
Yeah.
so your expansion goes in the following order. You have a number out in front, which comes from Pascal's triangle. We're going to fill that in. You have A to the exponent that's given on the outside. And then to find the exponent of B, you ask yourself, what number do I add to 4 to get back to 4? And the answer is 0.
Yeah.
Okay, so this is going to continue for a moment. We're going to simplify in a moment, but this is the breakdown. So then you have another placeholder for a number, and then you take A and you go down by 1. So you go from 4 to 3, and then the exponent above B is whatever number you add to 3 to get back to 4, which is 1. Hopefully you're seeing a pattern here.
Mm-hmm.
You have yet another placeholder, A squared, B squared, another placeholder, A to the 1, B to the 3rd, and another placeholder, A to the 0, B to the 4th. And you do see there's this pattern of descending exponent on the first one, ascending exponent on the last one, and so on. There are 1, 2, 3, 4, 5 placeholders. And in the 4th row, how many numbers do you see?
5.
5. So guess where those numbers go?
Yeah,
out in front. Okay, now this is not the answer, but we're getting closer to the answer. Okay, so it's not A in your problem. So this is my approach, by the way. This is maybe different than what you would see in the classroom, but it does get to the same answer. So it's 1 times, and your A is 2x. Notice I'm putting it in parentheses. Your B is +3, so I just leave it as 3 to the power of 0. Your next line is 4. Again, A is 2x to the power of 3. Your B is 3 to the power of 1. So again, all I'm doing is taking that A, which is 2x, that B, which is 3, and substituting it in each of these positions.
Yeah.
And we keep going here, 4 times 2x to the power of 1, 3 to the power of 3. And it's actually faster to actually write like all the 2x's to the exponents than all the 3's to the exponents. But you can decide how you do it. Just make sure that you're going down on one list and up in another. Okay. And these all add together. So we just have to figure out what each of these are now. Okay. Any questions up until this point on how to do this? Okay.
Yeah.
So when you're simplifying, you need to remember a few rules. 2x to the fourth means 2 times 2 times 2 times 2. X to the fourth, you're multiplying the exponents. So 4 times 1, x to the fourth. So this is 1 times 16x to the fourth. Anything to the 0 power is 1. And that gives you 16x to the fourth as your first term.
Mhm.
Now, you don't have to write anything I just showed as long as you get to 16x to the fourth. You could say, hey, for the first one, I know it's a 1. You don't even have to write this out. I recommend it because it helps for clarity, but the first one and the last one have some nice things about them because it's got a 0 there as well.
Yeah.
All right, but the second one here, it's 4 times 2x cubed. That's 2 times 2 times 2. That's 8 x cubed. 3 to the 1 is 3. So now you got 3 numbers to multiply. 4 times 8 times 3. And if you don't have a calculator handy, I don't know if you'll be allowed to use one, but you can multiply those out.
Yeah.
The next one is 6 times 4x squared times 9. So just when you're like, oh, that's these numbers are getting smaller in here, then you get a bigger number here. That's the way it goes.
Yeah.
Let's see, 4 times 9 is 36. 36 times 6 is 216. Okay. And we keep going here. So 4 times 2x times 27. So I'll go, what will I do here? I'll go 4 times 27 is 108 times 2 is 216. And then the last one, anything to the 0 power is 1. 3 to the fourth is 81. So even though this is your answer, you have to rewrite it in the form that they want. So you want to show it as a polynomial. So it's 16x to the fourth plus 96x cubed plus 216x squared plus 216x plus 81.
Yeah.
You will get one of these on your test.
Yeah.
They have to test you on this.
It's
There's
so long.
yeah,
Complicated.
there's no value of knowing this except for this test. Okay, that's all you're doing it for. It's not on SAT stuff. If you take a college algebra class someday, you might see it again, but there's no value for you. But this is the process. So we'll do number 2 together. I wouldn't dare ask you to do one of these on your own quite yet. It takes more effort. But it's going to be essentially the same thing here. So for the second one, you might say, well, hey, Matthew, why don't I just do minus x plus 4, minus x plus 4, minus x plus 4. I'll multiply these out. And you can do that. But your teacher might say, thou shall use Pascal's triangle. And it's kind of like when you had to solve a system of equations with like elimination or substitution. If you don't do it the way they want, you're not going to get credit for it. So you can't do this. Okay. But we can draw Pascal's triangle. So it's 1 at the top. That's the 0th row. 1 and 1, that's the first row. Then you add those two together. 1 and 1 gets you 2. 1's on the outside. 1, 3. 1 plus 2 is 3. 3, 1. And that's the second. And I stop here because this is the same as our exponent.
Yeah.
That's key. Don't need to go on forever. You don't get any value. You don't win anything by doing more than you need to here. So your A this time, your A though is minus x. And your B is 4, positive 4, but we'll just call it 4. So let me try doing this slightly differently here. There's a placeholder Okay. Negative x to the power of 3. You always match. These always match on the first one. Okay. And then it's b, and I always do it in parentheses, even if it's positive, to the power of 0. Because the 3 plus 0 has to add back up to 3.
Yeah.
Plus placeholder minus x to the power of 2. See how this 3 is going down to 2?
Yeah.
Okay. And then the other one is going to go up. It's going to go up. Plus, it's always plus, placeholder minus x to the power of 1, 4 to the power of 2, plus placeholder minus x to the power of 0, 4 to the power of 3. And then you fill in those placeholders with numbers from the Pascal's triangle.
Yeah.
So again, brief review. When you have a negative number, to an odd exponent, as you do here, negative x to the power of 3, it is we could write it out here, that might help here. 2 negatives make a positive, first 2, but then the last one makes it back negative. So it ends up being negative x cubed times 1, which doesn't change it, and 4 to the 0 is also 1, which doesn't change it.
Yeah.
So the first one is usually not that bad. Same with the last one, but you just go in order here. So plus 3 times, so negative x squared, negative times a negative is positive, x squared times 4. So minus x cubed plus 12x squared.
Yeah.
Then we go to the next one. It's plus again, 3 times negative x, and 4 squared is 16. We're on this third one here. So 3 times 16 is 48, and there's a negative x minus 48x. And then the last one, negative x to the 0 power is 1. 4 to the power of 3 is 4 times 4 times 4, that's 64. So it just becomes plus 64. So this is probably the way it was shown in the classroom.
Yeah.
I prefer this way. It's more tabular, but
Mhm.
both work. You should use the one you like, whichever one you think will work best for you.
Yeah.
And they can get as complicated as they need. Do you want me to go back to the previous thing you sent me from our last lesson and do a couple more of these, or move on to the other types of problems on this?
I think move on to the other types of problems, because the ones that the ones on these are like stuff that I missed and haven't learned like fully.
Okay,
So
very good. All right, so we'll move on to number 3. Okay, x squared plus 3x minus 28 over x minus 3. You always try to factor the numerator, and because what you're hoping for is there's a cancellation. So if you remember, this type is the type where you're looking for 2 numbers that multiply to minus 28, but add up to positive 3. I'll make a list here, but you can tell me if you see something that works, or if you already know which one works.
so you need something to add up to 3.
Yes.
Okay,
Do
so
any of these
it would be 7 or -7 or 7 and -4.
right. So you'd write x minus 4, x plus 7 over x minus 3. And unfortunately, nothing cancels.
Mhm.
Okay. And you probably won't get any, but I guess I would throw that out there. So this is what's called a polynomial long division problem. Okay, so here's how you do long division if you haven't done it in a while. You put the thing on the bottom outside the house. This is the language we use with kids learning division, believe it or not. X squared plus 3x minus 28 goes inside the house.
Yeah.
And you did not see this in class or didn't see enough of
Oh,
it
no, we did. Yeah, we
did.
did.
Okay. All right. Do you remember how to proceed from here?
Hold on, let me write this down. I think so. Don't you take the X first and you put it in?
We're trying to, yeah, we're trying to get, we really want to get x squared down here. So you ask yourself, what do you multiply x by to get x squared? And the answer is x.
Yeah.
So then you're not supposed to write this x squared. You just say, what do I need? What do I want to multiply to get x? Because you multiply actually both x and the minus 3 by x. So that's x squared minus 3x.
Okay, wait, hold on. So can you go over what you just did again? I kind of got lost.
Yeah, this is the important part. You take this x and you multiply it by x. That's x squared.
And where did you get that X from? Because the X goes into X squared that many times.
You're trying to get rid of the first term. Okay,
Okay.
so let me, this is just as a reminder here. Let's say you're doing 4 into 48. You say, how many times does 4 go into 4? One time, right?
Mhm.
That's why you put the 1 there, but then you multiply the 1 times the 4 because you really want to get a 4 in that first position. So it's the same thing here. It's like, we need to get an x squared. How do we get an x squared? We take x and multiply it by the x.
Okay.
Okay, well, it'll become clear as we do more. Then you take the x and you multiply it by the other thing by minus 3, becomes minus 3x.
Yeah.
Is that okay?
Mhm.
Okay, now this is really critical, this step right here. You change the signs. Do not subtract. I know we subtract here. You really want to change the signs, okay? And I
Yeah.
like to go minus plus, whatever it is, change the signs. If it's positive becomes negative, negative becomes positive, because then I want to add. I want to add vertically. Adding vertically is just so much better. All right, so what you should always get is 0 in that first position, because the whole point of what you're putting up here in the top is so that it cancels out when you're working through this. So what is 3x plus 3x, this middle term here?
It would be 6X.
6x, yeah. And just like in long division, you bring down the next term. Okay, so now your goal, I'll let you hang on, let you get caught up here.
Yeah.
Sorry, I apologize for rushing through it.
Oh no, you're good. I'm good.
Okay, so you want to get 6x. What do you multiply this x on the left by to get 6x?
5X or 5. Oh wait, it's 6. Yeah.
6, yeah, because there's really a 1 there. There's really a
Thinking
1
of
in front. Yep.
addition.
Yeah. And then so you multiply 6 times 1x. Let me show that in another color here. 6 times 1x is 6x. And then you take that 6 and you also multiply it by the negative 3 to get minus 18.
Yeah.
And again, super critical. I don't know how to get this. Like I really want you to do it this way. Change the signs to add vertically. The reason you don't do that in the old long division is, first of all, you didn't really understand addition and subtraction, but subtraction always worked out nicely because there weren't pluses and minuses. But here you really want to change positives to negatives and negatives to positives.
Yeah.
And it will help. It will truly help. Okay, so you get 0 again. Minus 28 plus 18 is negative 10.
Mhm.
This is your remainder.
And how do you know that that's your remainder and that's where you stop?
You have filled in this rightmost position. So let's go over here to the right and just remind you, let's say we want to go into 49. Okay. 4 goes into 9 2 times. 2 times 4 is 8. You're done. Like you've filled in as many positions as you can. So there's where you leave off your remainder.
Yeah.
So some other terms here that are important. This is your quotient.
Okay.
And this on the left here is called your divisor. There's a reason I'm doing this. Q, D, and R. So here's the most common way to write your answer: quotient plus remainder over divisor. It's the most common way. You should look in your notes or ask your instructor if that is how they want it. So you take the x plus 6, the part on top of the house, plus your remainder, negative 10, over your divisor, which was minus 3. The instructor is expecting some form of the answer like this. It's not good enough just to do all the work we just did.
Yeah. Okay.
Let's do another one. We'll do number 5. It's a little more difficult. Or do you want another example of sort of like this is the base case? Do you want another one like this
Yeah,
first?
maybe one more.
Okay, that's a good idea. All right, let's try. So it'd be presented this way: x squared minus 4x plus 8 divided by x minus 1. Okay, and you have to remember that the x minus 1 goes outside the house, and then the x squared minus 4x plus 8 goes inside the house. Like this.
Okay.
So you ask the question, you say, what do I multiply this x out in front by to get x squared?
And it'd be X.
X. Now you put that x in the x column. So there's an x squared column.
Yeah.
It
Mhm.
has to go in the x column. You can't mix that up. So then you take this x and you multiply by both of these on the left here.
Yeah.
And you line them up with the one that it matches with.
Yeah.
Okay, now if you got that, this is the part where I recommend changing the signs. Change the signs. So you subtract, you add, and then you add vertically. So that's 0 minus 4x plus 1x is minus 3x. And then you bring down whatever is left over.
Yeah.
Okay, so now your attention, just like your attention was on the x squared, your attention is now on the minus 3x. And you're looking at this x out in front again. It's like, what do I multiply x by to get minus 3x?
-3.
Yeah, negative 3. And that has to go in that position with the single number. And once you get that, you're like, all right, I got to multiply minus 3 by x and minus 3 by minus 1. Like that. And then change the signs. So you're going to make that a positive, change that into a negative, and then add vertically. 5 is your remainder. This is your quotient, and this is your divisor.
Yeah.
I don't have a good way to remember that. Check the internet. All right, so
Number Q plus R over D.
Right. And that's important. You got to be able to write it that way. So it's x minus 3. The way you write transfers, x minus 3 plus 5 over x minus 1.
Yeah.
All right, so let's look at number 5, which has got kind of a little wrinkle in it that's applicable to tests. I think your test will probably say to use polynomial division or use long division. I can't imagine it wouldn't tell you that, but
Yeah, I think it definitely will.
yeah. So there's a small problem with what's over here on the left. Do you see how it skips the x squared?
Oh yeah.
And that's why it's probably a test question or quiz question, because you're supposed to know, and you have to do this to be able to do it correctly. You have to include a placeholder for that one that's missing. So you use the 0. So somehow you want to make a mental note to look for that. I think we did some synthetic division problems where it was the same issue. So please be on the lookout for that.
Yeah.
Okay, so x squared minus x plus 1 goes outside the house. And then inside the house is x to the 4th minus 2x cubed plus 0x squared plus 4x plus 6. And give yourself enough space between the columns so that you can work this out. All right, so your attention is on x to the 4th and x squared. What do you multiply x squared by to get x to the 4th?
It would be x squared.
X squared. So notice I put it in that missing column.
Yeah.
All right, so then, and this is more work, but you take that x squared and you have to multiply it by each of these. So you get x to the 4th minus x cubed plus x squared.
Okay.
Okay, I'm going to make this first one negative, positive, negative. So that's minus x cubed minus x squared. And then you generally bring down one more term. So it's the same thing. You look at that leading term. So I'll highlight it. So what do you multiply x squared by? What do you multiply x squared by to get minus x cubed? So first focus on the how do you get to the cube? How do you go up one exponent from 2? And that's x.
Yeah.
The negative though, you have to do a negative x.
Yeah. Okay.
So now again, unfortunately, it's a lot of work. You got to take that negative x now, negative x times each of these, times each of the ones. So we got negative x cubed plus x squared minus x. And that's just me taking that minus x times each of these. It's okay if you got to come off to the side and write them out each time. You've got to be able to get the right numbers there.
Wait, so for these ones, do you not change the sign?
I'm going to here at the end.
Oh, okay, okay.
Yeah, sorry, just making some side comments.
No,
And,
you're good.
so now we are going to change that. I'm glad you caught that. I appreciate you really, please check me. The later I go in the night, the more I'm liable to make some pretty bad mistakes. Okay. Yeah. All right, so it's the same thing again. You look for that leading one. Your leading one here. And it's the same question. So what do you multiply x squared to get minus 2x squared? That's what you want to ask yourself. That's what you're thinking about here.
It'd be -2.
Minus 2. Perfect. So we're going to multiply each of those by this. Oh, I didn't bring down. That's why this is looking awkward. You have to always bring one down. We'll lose room here in this. All right, here we go. So it's minus 2x squared plus 2x minus 2. Okay. And then you change the signs of the other ones. So you end up getting 3x plus 8. So this is your remainder. All of this on the right is your remainder. They're down here in the bottom. And sometimes it's the number, sometimes it's expression. This is your quotient up here and your divisor.
So 8 is the
No, all of this is your remainder.
Oh,
Yeah, it's uncomfortable. It's like, what do you mean?
yeah.
It'll have a meaning later in this chapter if you get to that. I don't know if you will or not.
Yeah.
So you're supposed to write as Q plus R over D. That's the best way. I would ask your instructor if that's what he wants. There's another way to write it also that's equivalent. Okay, so can we move to some synthetic division problems, 15 and 16?
Yes.
Notice the instructions for 15 say to thou shall use synthetic division. I had that little bit extra, but that is the intent here is you must do that.
Yeah.
In college, it gets even worse. They sometimes tell you to do things you would never do one way. They're like, you have to use this specific thing. And you're like, why? But yeah, that's what they're preparing you for here. So just like we did in the last problem, you want to look and see, is anything missing? Okay, so it goes from a 4 to a 3 to a 2 to a 1. And you might think that nothing is missing, but there's a 0 actually missing here at the end. There always has to be a constant term.
Yeah.
All right, so we're gonna do this kind of different than the way that they want you to do it here, because I want to remind you how to do this. So these coefficients, 1, -1, 4, -4, and 0, they go in this sort of this table up here. And in the box, is the number that we think works for this one. Excuse me. Now, do you remember how we guess? Or I'm sorry, let me back up here. I think I mentioned like it might be good to ask your instructor if you're gonna be able to use a calculator to graph them first. Did you get any clarity on that?
Yeah, we do get to, we can use a calculator.
Okay, very good. So I'm going to graph this and find a number that works. We'll work through this. Why does this x fourth minus x? Okay. Really odd. All right. So we're going to try 1. Okay. So does 1 work? So remember, you bring this number down and then you multiply. 1 times 1 is 1. Add vertically. 0 times 1 is 1. Add vertically. This is not working. Hang on a second. Sorry, that's why this is a problem. I apologize. There's a mistake here. Why isn't this highlighting? Okay, this should be a 0 because 0 times 1 is 0, and then you add vertically. 4 times 1 is 4. Add vertically.
Yeah.
0 times 1 is 0. 0.
Okay.
Okay, so there's actually another 0 at 0. So we'll just keep going here. So again, you just bring that first number down 1. 1 times 0 is 0. You add these up and get 0. And then 0 times 0 is 0. Add these up. 4 times 0 is 0. And you get a 0 here in the last position. This was not a good problem for synthetic division, so I apologize. We really should show something different. But okay, so here's another important thing here. This was an x to the 4th. Then this 1 down here that I'm about to highlight was x cubed. This is an x cubed. Okay. So this last one is now an x squared. So the net result here is that you're down to x squared plus 0x plus 4.
Yeah.
Okay. And this is where you have to know to solve this using other methods. But the instructions say to only find what are called the rational zeros. And rational zeros means real. Real meaning no i's. Maybe I should say it that way. No i's, no complex roots. All right, so let me actually grab a synthetic division problem that's better than these, because this was really bad. I apologize. Just maybe see there's another one in your okay. All right, so let me grab this one. Okay. Just reset here. I know this one isn't on your worksheet, but I'd like you to see one that is a true synthetic division problem. So they generally tell you what you're dividing by over here on the right.
Yeah.
And that tells you what number goes in this box over here to the left. But to figure that out, you're setting y minus 2 equal to 0. So y equals 2, and 2 is what goes in the box. It's not -2, it's the number that makes this 0. And then you grab those coefficients, including the constant, and put them down this table. So will you try this synthetic division for me, please?
Yes. Oh, that's what I do. I was like, I didn't get 0. Hold on. Okay. So the numbers I got are 1, -6, -2, 2, and 0. And -2, yeah, -2 actually. I think you're on mute. I don't know if you're talking or not.
Sorry, I was talking. You actually answered me like I was talking. It's amazing. All right, so the root works because you get 0 at the end.
Yeah.
That's important. Okay. So we don't know what else to try. To do that, let me just graph this one and see what we get to come up with here. How's your grade in the class? Have you seen any improvement?
It's improving a little bit because of the test score I got. It's just we haven't done much, so nothing's like been boosting. But after this test, hopefully it'll raise.
Okay. Yeah, I hope so too. Actually, there's no other ones that work nicely with this, so we will move on to something else. But that's synthetic division. That's so that the summary of this part of our lesson is you will get a problem that says do it using long division. And you usually get at least a problem that says do it using synthetic division. And you have to be comfortable doing both. Hoping that it doesn't happen is not a good strategy. It inevitably will.
Yeah.
All right, let's go back to number 4. Okay, this one, it's in this category of simplify the polynomial. Really, this one is your options here in this section are add, subtract, multiply, or divide. And we've already covered division. This one is a multiplication. And I think we talked about this style of problem last time where you take that, you start from left to right, but you multiply each of these by that x cubed or whatever it is. So when the bases are the same, you add the exponents. So the first x cubed times x squared becomes x to the 5th. If the exponent isn't given, it's 1. So this becomes minus x to the 4th plus 4x cubed. And then you take that second term with the sign. I don't know if you like colored pencils. Some students actually do colored pens and things. I think it's really helpful if you're up for it.
Yeah.
If you're willing to switch between them. So now you take that minus 2x times each of these. Now it's minus 2x cubed. The way I was showing you the other day, I think, is to line them up vertically. It's actually a lot like the division where you want them all kind of in the same column. Plus 2x squared. So you add columns when you need. Minus 8x. And then again, you would add vertically. So if there's nothing to add it with, it just comes with. And that is your final answer.
Oh, that's pretty easy.
Yeah. Now I'm shocked that a problem like number 8 is on here. Maybe it's there just to see if you're paying attention.
Do you just distribute the exponents to both?
That is the mistake. That's the classic mistake on this problem. You're actually supposed to write it out.
Yeah, and then foil.
And then foil, yeah. So if you've got, once you get this written out, if you could foil that for me, I would appreciate it and simplify like terms.
Yeah. I got 4x squared minus 20x minus 25.
Check the sign on that last one. What are you multiplying?
Oh, plus 25, two
Yes.
negatives.
Yes. Like if you were taking an SAT style test, that both those would be there, positive and negative. All right, so really quickly in the got a couple minutes left here. We'll go right up to the hour.
Could we actually do number 16?
See if we got time for that. Okay,
Or
yeah.
just like explain how to get started maybe.
Yeah, I'll work it out here. It does say to use synthetic division though, which is not the best way to do it. But so, okay, let me remind you here that this is x to the fourth plus 0x cubed minus 5x squared plus 0x plus 4. And that's critical. It's critical that you provide those missing ones. Now, when you go to your calculator and graph this, you will find all the roots. So there are roots at the following: -2, -1, 1, and 2. So I'm going to start with the positive one, put that in the box. 1, 0, -5, 0, and 4. And then this is where you do your synthetic division. And we know 2 works because I told you it works from the graph. So you should get 0 at the end. And this is where you want to keep going. You don't want to rewrite it. You want to say, all right, let me try 1 because I think 1 works because I looked at my graph. And you do synthetic division again. You should keep getting 0 in that last position. And you can actually keep going. -1 works. So you bring that 1 down. And then you keep going yet again. -2 works.
Yeah.
So that's the correct way to do it for this. Although in full, full disclosure, you probably would stop at this line right here, this x squared plus 3x plus 2. Right here, and you would just factor from here. That's generally, that's generally where you stop when you get it down to a power of 2.
Yeah.
Okay, that's everything. That's all we got for tonight. I'll send you the notes here shortly. It might take me an hour, but I guess we got another lesson coming up. Not sure.
I don't think I've scheduled one.
Probably need another lesson to go through the rest of this. If you end up scheduling, we'll just keep going.
Yeah, I'm pretty sure I'll probably have one on Sunday. That's when I usually do them.
Sounds good. Thank you so much, and I'll see you next time. Okay, bye now.